Mrs. Vara here. We are going to be looking at section 4.1. So this is AP Calc, first section of Unit 4. So Unit 4 is all about applying or interpreting or using the derivatives that you learned how to take in Chapter 3. So it says here in Units 2 and 3, we did a lot of work finding a derivative. Now we'll turn our attention to what the derivative means in context of a problem. So this is from a previous AP exam. I'm going to zoom in a little here. So it says the temperature of the water in Celsius in a pond is a differentiable. So you want to be looking for those keywords. Function W of time, so time is your input, temperature of the water is your output. The table to the right shows the temperatures as recorded every 3 days over a 15-day period. Remember, if they tell you a function is differentiable, then you know that it is also continuous. So even though we only have certain points here, we know between there it is continuous. Then it says use the data from the table to approximate. So whenever you see the word approximate the derivative, that is Algebra 1 slope, which makes sense because we don't have the function to do the actual derivative. All we have are coordinate points, so we're going to do an Algebra 1 approximation at time equals 12. So how would I label this? W prime of 12 is approximately equal to, so if we look at 12, there's our 12. So we probably, to approximate 12, we want to use these 2 points next to 12. So my y2 minus y1 would be 21 minus 24 over my x2 minus x1, which would be 15 minus 9. And we would get negative 1/2. So this is a rate. The y value is temperature. The x value is days. So this would be degrees Celsius per day. Okay, now I really need to zoom out, sorry. So what if we're asked to interpret the meaning of the approximated derivative we found in example 1. So interpreting the meaning of a derivative in context of the problem means you have to use the words from the problem. So this NUT acronym will help you. So when you're interpreting, you want to make sure you include a noun, whatever the problem is talking about, units, and a time at which the derivative or change was computed. So in example 1, we're interpreting the meaning of the derivative from part A in the context above. So if I were interpreting this negative 1/2 degrees Celsius a day, I would say the temperature, I'm going to abbreviate that, of the water. So there's my noun, right? That's my N. Temperature of the water in the pond is decreasing because the slope or the approximate derivative was negative, is decreasing by negative 1/2, or you would just say actually 1/2, or 0.5 degrees. There's my units, Celsius, per day. There's my time. So noun, unit, time. Okay, turn the page. Let's look at another example from a previous AP test. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at the gravel processing plant is represented by this. Okay, so this is a rate. So it's a rate of change, which you can think of it as a derivative, because it says the rate. So when you see rate, derivative is a rate of change, slope is a rate of change. Where t is measured in hours between 0 and 8. And then tons per hour. So tons is your y, time is your input. At the beginning of the workday, which they're saying is when time is 0, which normally when time is 0, that's at the beginning. The plant has 500 tons of unprocessed gravel. During the hours of operation, 0 and 8 hours, the plant processes the gravel at a rate of 100 tons per hour. So this is telling you another rate. So it says find G prime of 5 using correct units, interpret your answer in context of the problem. This was the scoring rubric for this problem. So it was 2 points, 1 point for finding G prime of 5, and then you can see another point for the proper interpretation. So this is also a calculator active problem. So to find the derivative at time equals 5, remember on a calculator active problem, use your calculator. So we're just going to say, and we are going to say approximate on that because when we put this in our calculator, we're going to be rounding to 3 decimal places. So you want to do math 8 and deriv with respect to x. Hopefully you are in radian modes. Hopefully I'm in radian modes. And then you want to input that function 90 plus 45 cosine parenthesis. Ooh, actually I already had a parenthesis there. Let me delete that. Parenthesis x squared divided by 18 at 5. Okay, so type your function in. That's a little bit tricky to see. Hit enter, and you should get approximately negative 24. So 0.5875, you need 3 decimals, either rounded or truncated. So 0.587 or 0.588. I'm just going to do the truncated. Okay, so that would get you the first point. All right, and then the second point would come from interpreting your answer in context. So we need a noun. The noun in this is the gravel. We need a rate. Well, we know the rate is tons per hour, and our time would be at time equals 5. So you would say the rate, and then go to the question they asked. Where's the question? Using correct units, interpret. Oh, the question is just interpret the derivative. The derivative is the rate of change at which the gravel is arriving in the plant. So this function up here told you that this is when the gravel is arriving in the plant. The rate at which gravel is arriving. So you do want to do the arriving because they gave you another rate here, which was the rate it was processed. So you want to make the distinction that you're talking about when it arrived. The rate at which the gravel is arriving at the plant is decreasing. By 24.587 tons. There's your unit. Your noun is your gravel up here when t equals 5 hours. There's your time. So noun, unit, time. I think we only have one more. So let's do one more. Also from a previous AP question. So this is all just about interpreting correctly. So the wind chill, that seems nounish to me. The wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit. So that's thinking that's going to be my units. And the wind velocity. Velocity is a derivative, right? In miles per hour. So that also tells you velocity is a rate. Velocity is a derivative, derivative is a rate. We know it's a rate because we have miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill, this is wind chill, I would label it if I were doing this problem. The wind chill is given by that function and is valid between a velocity of 5 miles per hour and 60 miles per hour. So that V is a velocity. Okay, find W prime at 20. So that's a lot of reading to figure out. They want us to find the derivative of the wind chill when velocity is 20. Using correct units, explain the meaning in terms of the wind chill. So first point, not too bad. W prime of 20 is going to equal approximately. I'm going to say at this point, you should pause the video, put this in your calculator, and at x equals 20. So hopefully you pause the video, put that in your calculator, and you should have gotten negative 0.2855. And this is degrees Fahrenheit per miles per hour. So degrees in Fahrenheit and miles per hour. So, well, we're going to actually put the units when we interpret. So the value, which is the first point, is this. And now we're going to say, I'm just going to repeat this, 0.2855 degrees Fahrenheit in miles per hour. So think about this. This was a rate, and then we took a derivative. So it makes sense that we have a rate for our denominator here. It's almost like acceleration when you get seconds squared, because this already was a rate, and then we took the derivative again. So this is the wind chill is decreasing because it's negative by a rate of 0.2855. Hopefully you did your 3 decimals there. Degrees Fahrenheit, miles per hour. If you're wondering, did I have to write it twice? The answer is no. At a wind speed, or wind velocity, so think for this function, the input was not time, it was velocity. So the input was velocity, and it was when at a wind velocity of 20 miles per hour. Okay, so the wind chill is our noun. Our rate is degrees Fahrenheit. And our time is not really a time in this problem. It's another rate. But it is your input, so it's time-ish. You can think about it as time-ish. Our input was velocity instead of time. That is it for 4-1.